Hi, welcome to Lecture 8B. This is Future Trends in Construction, Change Becoming Reality, and this is in our Intro to Construction course. If you missed Lecture 8A, probably best to start out with this because this is kind of a continuation, and I didn't want to make 8A too long before you get a break. So go back and take a look, and then it will make better sense to you. But we are talking about emerging trends in construction, future trends in construction, as I like to say. And some of them that tie to use in building information modeling is the ability to laser scan technology, where we can scan existing buildings and we can quickly know exactly what sizes and spatial requirements of the existing condition we're dealing with. Can be very, very helpful that way, and helpful in the integration to 3D BIM modeling so that we have high levels of accuracy that way. So it also can be very helpful for topography, topographical scanning to get a better understanding of the geospatial survey that we're working in for a particular project, and to be able to convert that information over to a BIM model. So all kinds of scanning technology that's available and becoming more advanced by the day, really. So laser scanning allows you to get an accurate scan of things and then convert it into a model, and that makes saves tons and tons of time. Plus, it's accurate. Whenever you do things by measurements and that, you've got another step where likely you've got things that aren't accurate. That's why prefabrication hasn't been as widely adopted in construction in the past, is because very often you prefabricate something and then it doesn't fit in the assembly. The better we can scan existing conditions will allow us to prefabricate things, that piping systems, duct systems, all kinds of assemblies, and with some assurance that it will actually fit later in place. So that's very, very helpful from that perspective. And it can be used for forensic purposes after something has happened, some sort of issue, something occurred. It can be utilized to scan existing conditions, see if there's any settlement and how much settlement, for investigative purposes and reconstruction purposes, and to mitigate issues. So it has a lot of purposes wherever we've got existing conditions. And when we start talking about topography, where do we not have existing conditions? So very, very promising in its use and conversion from a scan to a model. Then we have the whole area of mobile technology, and I probably mentioned in an earlier lecture. Again, you can be taking all kinds of photo documentation that can be converted into drawings, can be converted into a variety of different uses. But really mobile technology too, I think of mobile technology as all the productivity softwares that are being developed, that are currently in use, and that are constantly evolving and expanding their uses to areas that we didn't even think of. And so productivity software, some of the best examples would be like Bluebeam, Procore, FieldWire, to name but a few, where you can log all your RFIs, your submittals, your photo documentations. You can track your punch list. You can track hours of work. You can quickly access that information, manipulate the data to give you responses to particular questions that you may have. And that's going to advance our ability to increase in product, basically catch up to the other industries that we talked about in Lecture A with regards to productivity, improve our productivity substantially. As I mentioned in Lecture 8A, construction's improved but less than 1% per year, really over the last 50 years. And mobile technology, I think, holds a lot of promise in this particular area. As well, you can quickly communicate, you can get answers, you can take a picture of a particular condition, you could send it to the consultant, get a response back very, very quickly. And anything that removes lengthy steps in the process is going to have a positive impact on our ability to do things in a much more fast and efficient way. So mobile technology holds a lot of promise there. And you're dealing with things that are dynamic. So we think about in terms of technology and the adaptation of technology in any kind of industry. There's what we call static systems and dynamic systems. So a dynamic system means that in the case of technology, you've got the information in the cloud. You know, I know it's kind of a cliche to say that, but as you change something, somebody else can see what you changed live. And you don't have, it's not that you change something and then they're looking at something older. They can, if it's properly organized and accessible, you can go back and look at different versions, but you know what the current version is. So there's absolutely no way of making a mistake for what's current and, oh, well, that was last month before we did these 3 changes. If you did the 3 changes and you logged the 3 changes, it's right there in front of you and it's listed that you know this is the current approved documentation. Or if its status is not yet approved, but it's pending, you'll know that it's pending. And so that's, you would not believe how helpful that is in the construction industry, because there's so many mistakes that are made by looking at something that was the current document a month ago, but something changed since then. So you have subcontractors that are working off something that's a month old, and then they get so far down the path. What are you doing? You got to redo it. Millions and millions and millions of dollars can be saved by having a system in place that ensures that you have a dynamic system and not a static system. So in the old days, you'd fax something and you put it in a file folder, but not everybody had access to the file folder, and then somebody did something with something before. Not good, not good. Just opens it up for a lot of mistakes. So mobile technology really has a lot of opportunities where we can actually look at the BIM model. We can view it right in front of the site, compare it to what work is going on right in front of us. And we don't have to plot it and print it and all of those particular things necessarily. Print documents still have their place. But I also suspect within a short period of time, nobody's going to be printing anything that way. People will say, well, you need the big space for drawings. Well, right now I've got a pretty big screen in front of me that I could pretty much review any document that I'd want to the size that I want. And I can zoom in, zoom out. And with somebody that doesn't read too well without glasses, it's such a bonus as opposed to trying to read something that didn't print that well or the right scale on the print document. Big improvements. And so, yeah, as I was mentioning, you can be looking at what's actually been built and does it match the BIM model, and then what other piping are we going to be installing, and is there capacity for it, etc. So this is also too where you could tie in scanning technology with mobile technology. So that aspect of mobile technology and changes not being static but being dynamic, and being able to follow that through, and that continuous communication that can go from the consultant to the GC to the actual site very, very efficiently, very, very quickly. We're also other things. This is, I would say, more future-oriented, but wearables, virtual reality, or augmented reality, as they want to call it, where you can actually put them on. It orients you where you're in the room, and you could be in the same room where the finishes are not on the walls yet, but as you turn your head and you move around, it shows the room with the finishes or whatever level or layer you want to see. This can actually be quite useful too. I can see some of these things changing to the extent where layouts can be quickly done and scanned, so that if we're going to do drop ceilings, all the layout points are posted on the ceiling, so we just have to drill wherever we have the locates, so it won't be so time consuming to lay those types of things out, where typically it would be a lot more time consuming. So there's a lot of these technologies that maybe aren't in full force yet, but in varying forms can be actually utilized that way. So that's the wearables aspect and how that can be utilized, and also the mobile technology tying into it from that perspective. Near field communications, and then you get into things like tracking of deliveries, RFID tags, radio frequency ID tags, and it's almost like the supermarket or the stores where you've got little tags and you cross through it and it beeps, that sort of thing. Well, that same kind of technology can be utilized to show where materials are stored on site, that they've been delivered, to track them. It can be helpful from that perspective. In some cases, I suppose if it's stolen off the site, it'd probably be able to be identified where it went to. So there's all kinds of this technology that can be utilized from that perspective. I know when they did the Art Gallery of Ontario, they used similar types of technology for it. 3D printing, another one that comes into the fold here was 3D printing and 3D construction of different elements. At George Brown, we have a number of 3D printers, and you can actually print out plastic sort of scalable foundation walls and parts of buildings and all these different elements. But if you actually go on YouTube and you search 3D printing construction, you'll see a lot of interesting different things that can be done, including laying bricks, laying blocks, forming walls, all sorts of things that can be done similar to this aspect with a 3D printing. So it doesn't always have to be just a small item. There's going to be these different tools, and if you come up with some sort of modular design, modular repeatable design that's designed to utilize this kind of system, there can be some extreme improvements in productivity rates with them. Now, I suspect in the beginning the quality is not going to be too good, and there's going to be some issues with it. But then what happens is, over time, the quality improves, the technology improves, and then before you know it, there are lots of different applications for its use. And it can be a disruptive industry as well. So I think about change in two ways, and I think I mentioned it in the first lecture. There is continuous improvement, so things that we tweak to do better, right? So when we talked about in lecture 8A productivity improvements, there's continuous improvement. Lean construction likes to think a lot about continuous improvement. We can always do something a little bit better. We can always be a little bit more productive with it. If we adjust things, we change things, or we change things up in our approach, our methodology. Then there's disruptive technology, and that's where it just changes a whole sector or industry. Now, disruptive is, as it sounds, it usually affects a lot of people in that industry. So, drywall, it disrupted the plastering industry. Traditionally, they used to, if you ever do renovations in old houses, there was wood lath and strips of wood, and then they would put what they called a scratch coat. Plasterers had to be very skilled. So they had lathers. These people, they went in the round, they put all these strips of wood. They would left a little space. And then the plasterer would come and they would put a scratch coat. So they're very skilled. They would put a coat that would line itself over the little strips of wood, and a little bit of the plaster would fall behind the woods and it would hook on. They called that the keys. And then they'd come back, and that first coat was a scratch coat because they just run a little scratch over it to make it rough. And then they come over it and they put a brown coat. Not because the plasterers were so skilled, they could trowel it on perfectly smooth and straight. And then they come back and they put on the putty coat. The putty coat was the nice white plaster finish that you would see. And they would just skim that over it and make it nice and smooth. You paint over it, was beautiful. And plaster was actually a nicer finish than drywall. But then they went to what they called gyprock lath. So that they had lather still, but they put the gyprock lath, and it was about 16 inches by 4 feet. And that didn't really disrupt the overall plastering, but it did mean that you could do it a lot faster. And then at a certain point, they came up with drywall. Well, now drywall, you could tape the drywall, which would be the finish that you put on drywall. But you could do one drywall taper could do so much compared to what a plasterer would do. All of a sudden, you didn't need so many plasterers. You know, you needed like maybe about 10%, 15% of the plaster. Plasterers had the choice. They could, you know, keep in that little market, or they could become tapers in drywall, but it wasn't this huge sector that it was. Now, if you're a plasterer and you know how to plaster, you're in business because there's not too many of them, and you're in restoration work and heritage work and all that sort of thing. But at the time, that would be what you call a disruptive change. It's changed the way things are done in this particular trade area. Well, 3D printing has that potential in certain sectors. Where they are exactly, that's why this is future trends or emerging trends that we're discussing. But there will be some sectors that will be disrupted as a result of that. And you as students of construction management, one of the advantages that I see is that I can't see total disruption, at least in the next 20, 25 years in construction management, because I think a lot of these technologies require more, if not, don't require less, if not more management abilities to coordinate all this extra work and to coordinate all these particular items. But in the trades, there will be some areas that will be more affected than others, and it depends on the trade, etc. So I would be very cognizant of those things when we talk about emerging trends in the construction industry. And as I mentioned before, virtual reality, and there's the augmented reality aspect, gives you a really good understanding of the 3D experience and what you're actually looking at in the actual finished product well ahead of when it's built. And so that ability is very, very possible. And to be able to construct a building in a virtual environment, meaning that you can animate, and that's 4D scheduling, as I talked about in the last example, where you can actually, you develop the schedule, you take the model, and you tie the objects in the model to your construction process, and then you can look at how it's being constructed, and you can identify areas where perhaps there's problems, where maybe it's not the most efficient, and make changes to the model, and then that can change how you actually plan the work and do the work on site, which can make things more efficient. So I think from that perspective, we should be thinking about all of these technologies are working collaboratively together to, as I mentioned before, to reduce the variation and to make things more reliable. You know, drones, first they were like toys, or they were the military for surveillance or for bombs, etc., unfortunately. But they also have some good purposes in construction work. Like I used to, at one point I was trained on a swing stage, and if you had to go on the outside of a building on a swing stage, it was a lot of setup and a lot of stuff to investigate something going on the outside of a building. Much better, you can do a drone with basically high definition camera, and you can fly it right close, and you can really take a good look at what's going on. You could never do that before. So this is really easy to do. You can also take a topographical view of what's happening on the project, and you can get a really good idea. You could get a really good idea about whether it's efficiently laid out. There's all kinds of uses for drone technology in construction, like unprecedented aerial images better than Google Earth. Many construction sites are using drones for surveying, mapping, to create 3D renderings of a project. doing surveys. Drones can record the actual progress and conditions of a project to help you with real-time project tracking. And they can be used, as I mentioned already, for inspection purposes. So it can be very, very helpful from that perspective, the use of drones. And all of these things, they're integrating together with a lot of different purposes. But if you want something to be successful, if we're talking about future trends, what's going to be the most successful is things that improve productivity. And if you improve productivity, some of the things that improve productivity is you improve quality. You have less rework. You are able to do it more efficiently and faster. You are going to be able to do it for less money, because if it takes less work hours to do it, that's going to be less costly. So all of these things, I don't think there was one that I mentioned is designed around slowing things down. It's around being able to do things more efficiently, more effectively, more reliably, more predictably. And so that is leads to being more productive. So that's what I wanted to cover in this shorter session. I'm Tom Stephenson, hoping you're thinking to the future and you're still in the present at the same time, and we can still learn from the past, and wishing everybody a wonderful day. Bye for now, and we'll see you next time.